Okay, so we're on to question 6. Figure 6 shows solid ice on a car's rear window.
The infamous ice car in upstate New York has been freed by a tow truck, leaving a shell behind.
So here we go, you can see it's melting away. The glass window contains an electrical heating element. Use the particle model in figure 7, this picture, to describe how the heating element causes the arrangement of ice particles to change as ice melts. Right, so this is the kind of thing that you'll have done since year 7 probably. So you've got like a picture here of solid particles all together, close together. I shouldn't really say solid particles, I mean the arrangement is that of a solid. And then the arrangement here is that of liquid. So it says, use the particle model to describe how the heating element causes the arrangement of ice particles to change as the ice melts. How does the arrangement change? Right, so the simplest thing to do would be to start with the description of what's going on here. So as a description of what's going on there, I would say we start with regular arrangement. Let's use a different pen. Regular arrangement. There's a regular arrangement of particles and they are vibrating about fixed positions. So vibrating about fixed positions, they're sitting where they are, jiggling around, right? And it says, how does the heating element cause the arrangement of the ice particles to change? So what's the heating element doing, right? The heating element increases the vibrations. So what's actually happening is, as it gets hotter, the particles are going to vibrate around more, and the space between the particles will get larger, and eventually the vibrations will become large enough that they can break the bonds and start to move around freely, right, which is how they are in a liquid. So the heating element increases the vibrations. I'm going to put in brackets internal energy. Internal energy is just like another way of saying heat, really. It means the total amount of kinetic energy of all the particles, so each of these things is going to have a certain amount of kinetic energy as they go whizzing around, and they're also going to have a certain amount of energy stored due to the electrostatic attraction between the particles. So it's sort of like when you rub a balloon on your head and it sticks to your head, it's attracted to your head. Well, on the atomic level, very, very small, chemical bonds and any kind of bonds are to do with electrostatic forces of attraction between these particles, and you can sort of stretch those bonds and store energy in them, just the same way you can raise any object up and store energy in the gravitational field. It's the same kind of thing. So internal energy is just another word for thermal energy, really. So heating increases the vibrations, internal energy of the particles, of the material. We'll stop. Eventually, the particles can break their bonds and are able to move around freely, but are still in close contact. So we've not quite got to a gas yet. They're not moving around freely. They're still able to swap position with each other, etc. Okay, so that's my best attempt at getting all 6 marks. We'll see if I've got them at the end. Let's move on to the next question. A car manufacturer tests different heating elements, measuring how long it takes to melt ice to melt. During the test, some variables must be controlled. Identify 2 control variables in the car manufacturer's test. So when it says control variables, some variables must be controlled, right? If you wanted to find out what was the best diet pill, you wouldn't test it on 50 people who are doing exercise and 50 people who aren't, right? You'd want to make sure that they all did the same amount of exercise or they all didn't do any exercise whatsoever. That way you could know for sure whether your diet pill worked or not. So with this one, you could have a manufacturer trying to cheat by sticking loads of ice on the windscreen so that their competitor's heating element doesn't appear to work. So we want to keep it a fair test. We've got to control everything that might make it possible for a manufacturer to cheat. So will the colour of the car affect this? No, I don't think so. Will the current in the heating element affect this? Yes, we should keep the current the same. Will the mass of ice on the thing affect this? Yes, we should keep the mass of ice the same. The size of car doesn't really matter. The time taken for the ice to melt is what we're measuring. That's what we're actually interested in finding out about, so that's definitely not going to be controlled. Another key point to notice here is this was worth 2 marks, right? So you knew you had to tick 2, right? Whenever you read these questions, it's worth going through and highlighting these types of things. These are the kind of things you need to go back to at the end of the exam to check that you haven't lost any marks. Right, next bit. Right. Some of the energy supplied by the heater causes the ice to melt without the temperature of the ice increasing. Okay, what is the name given to this energy supplied by the heater? Tick 1 box. Okay, again, so exam technique, it says tick 1 box. Watch out for these things, just 1. Right, so they've all got this word here, latent. Latent, latent. Latent means hidden. And actually, if you look at temperature against time whilst you're heating something, say you get a block of solid ice, the temperature goes up, 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 up until it hits 0 degrees Celsius, right? 0 degrees Celsius. And then it stays the same for some time, and then it starts to go up again, right? This little bit here is when it's melting, right? And then it goes up, and then you get all the way up to 100 degrees Celsius. I'm just using water as an example. When you get to 100 degrees Celsius, again, the temperature seems to stay still for a while, right? Again, we're putting in energy here whilst it is boiling, right? That energy we call, for either of these steps, is latent heat energy. The energy that goes in, but you don't see any effect on temperature. Sort of a hidden heat, right? Now, we've got to name this, right? So, the energy required to go from here to here to melt all this ice would be called the latent heat of fusion or freezing, and the energy to go from here to here would be called the latent heat of vaporization, to turn all that liquid into a gas. So what are we trying to do here? So it's melting. It's melting, so it's not the freezing one. Well, I'm going to go with fusion. Latent heat of fusion. That is the energy required to either needs to be taken out to either go from here to here, that way, or it's the energy required to be put in to go from there to there, either way around. So it's the latent heat of fusion. Okay, it's a bit naughty of them giving you the latent heat of freezing, because I think that could easily throw you. I think that could have been a fair answer. If this wasn't available, I would have gone for that one. But I think latent heat of fusion is the correct term, so I'm going to go with that. Okay, I think that's the last question. So it's a calculation, efficiency. I have to use my calculator. So when the heater is supplied with 120 joules of energy each second, the internal energy of the ice increases by 45 joules each second. Use the following equation to calculate the efficiency of the heater. Efficiency equals energy output divided by energy input. Give your answer to 2 decimal places. Look at that. There's definitely going to be a mark available for getting your answer to 2 decimal places. So, don't take a shortcut. Just lay out your formula, out over in. Stick the numbers in. So what was the energy output? The input energy, what we were supplied with, 120 joules, right? So that's 120 on the bottom. And then the energy that we were interested in, that we wanted to increase, the 45 joules every second, was going into the ice to melt it. That was the useful output. So 45 over 120. Okay. Being a bit naughty today and using my phone as the calculator. So 45 divided by 120. Try and do it in my head, but I can't. 120. 45 divided by 120. 0.375. So I want this to 2 decimal places, so I'm going to have to do some rounding. So this last number is above, is at 5, so I'm going to round up. So we'll have an answer as 0.38. Okay. Right, I hope you found this useful. Thanks for watching. Please like, subscribe, share, and all that business.
硬邦邦的了啊，眼睛瞪白了啊！哎，小手给我，
比真的大。
手厉害了。干嘛呢？
这个过程需要几分钟？
要，要几分钟？这颜色更快了。
用白了哈，一会儿就行了，一会儿就换过来了。
换吗？
换。
它眼珠变黑了就行了，眼珠现在白的。哦。
也是还原是黑的。对，混动还原的黑。
来，我去。
来。变黑了就行了。开始了，开始变黑了。你看，慢慢开始变。来，行了
哈，
行了，
它冒泡了。
就是2分钟到3分钟，
是吧？看吧，哎呀，看回血了，回血了，你看，你看，你看，你看，
这个要冷冻时间长都不能活了。你要保存。